When you need to solve exponential and logarithm kind of questions, okay, these are few of the guidelines that you have to follow. Okay, number one, this is something that students always miss out. They don't know when to sub t equals to 0. Okay, so it's for initial value. That means when your time haven't started, you sub in t equals to 0 for the initial value. Is actually to find some unknowns that is in the question. Okay, so you need to sub t equals to 0 first to find some unknowns in the question. Okay, number two, use ln and log law. For log and ln law, you must know. Number one is the power law. That means log base ax to the power of r, the r can come down, r log ax. Number two, if you combine the log a u plus log a v is equals to log a uv. Number three, log a u minus log a v equals to log a u over v. And number four, the most important is if you have log base ax equals to r, x equals to a to the power of r. Okay, actually there's one more. For example, you want to find 2 to the power of x equals to 7. You use log base 10 on both sides so that the x can come down. X log 2 equals to log 7, and hence x equals to log 2 over log 7. Okay, next one, as t becomes very large, this is also a very important concept. E to the power of anything, okay, will approach to 0, will become 0. Okay, this one I'll discuss in one of the questions below. And if you need to sketch the graph, remember if you have a constant in front, this is the asymptote or the dotted line. Okay, so a typical question is like this. An object is heated until it reaches 44 degrees Celsius. So this is actually called the initial temperature, but the question will not tell you that this is the initial temperature. You have to understand that I heat until 44 degrees. My time then start when it lets it cool. Okay, the equation given is t equals to t naught plus 16e to the power of negative 3 over 4t. Sometimes the negative 3 over 4 is a constant that you have to find. Okay, in this case, the first part of the question asks you to find t naught. How do I find t naught? Always when small t equals to 0, when my time haven't started, my big temperature is equals to 44 degrees Celsius. So 44 is my big T, equals to t naught plus 16 e to the power of 0. E to the power of 0 is equals to 1. So 44 is equals to t naught plus 16. So therefore, t naught is equals to 44 minus 16, which is equals to 28 degrees Celsius. Okay, so part 2 and part 3 are standard questions. That means they will ask you to sub in a value and then find the other value. Find the value of small t when big T is equals to 30. When you already have your t naught, which in this case is 28 degrees Celsius, you must use it. Big T equals to t naught 28 plus 16 e to the power of negative 3 over 4 small t. The question asks, what is the value of small t when big T is equals to 30? I put in 30 equals to 28 plus 16 e power negative 3 over 4t. Okay, now at this part, students will see the e and very excited use ln already, but you cannot do that. You can only use ln if there's only e power something on one side. So I must bring the 28 over. 30 minus 28 equals to 16 e power negative 3 over 4t. That will give you 2. Divide by 16 first, equals to e power negative 3 over 4t. Now you can ln both sides. Ln 2 over 16 is 1 over 8. Is equals to ln e power negative 3 over 4t. When you see ln e, it will just negate each other. You're left with negative 3 over 4t equals to ln 1 over 8. All you need to do now is to key into your calculator. T equals to ln 1 over 8 divide by negative 3 over 4. Don't think that, oh, I will get a negative answer, then you start down there, it's wrong. Because when you ln a number that is smaller than 1, this guy is actually negative. Okay, so just use your calculator, ln 1 over 8, then divide by negative 3 over 4. okay, you will get 2.77. Okay, 25, approximate, do your approximation, approximate to 2.77 milli. Okay, very important, you can only use ln when you have E alone on one side. Okay, so part 3, simple again, just sub the small t into the equation. Big T equals to 28 plus 16e power negative 3 over 4 bracket 2. Key the whole thing into your calculator. 28 plus 16 times e power negative 3 over 4. Okay, and then multiply by 2 to the power. Okay, and you will get 31.57. Approximate to 31.6 degrees Celsius. So of these questions, part 4 is the most important, so I will put it in red. Okay, find the approximate temperature when T becomes very large. Alright, this is your starting equation. T is equals to 28 plus 16e power negative 3 over 4t. When we explain, we always start with as T becomes large, e to the power of anything will go very close to 0. So you use approximate. Alright, why is this so? Because in the graph, remember e power negative, it is a aeroplane landing. When your T goes very large to 100, 1000, 1 million, your graph will go very close to 0. But because there's an asymptote there, it will not cross the 0. That's why you can only approximate to 0. You will go very close, but like 0.000000001, but it will not become 0. Okay, so therefore TA is approximately equals to 28 plus 16 times 0. Okay, that will be equals to approximate to 28 degrees Celsius. And what does this mean? That means at times, as time goes by, okay, your temperature will go very close to 28, but will never exceed 28, but will go very close to 28. What is 28 degrees Celsius? This is the room temperature. Okay, so as T becomes large, always start arguing by saying that e power negative something will always approximate to 0. Sub the 0 into your e power something, and that is the approximate temperature or approximate value of whatever that you need. Okay, and to draw the graph, I have gone through in the video previously. So big T equals to 28 plus 16e power negative 3 over 4t. First, use your ruler to draw the axis, x-axis, y-axis. When it's talking about small t kind of graph, we are only looking at the positive part because time is only positive. Okay, there is an asymptote at 28, so use a dotted line to draw 28. And what's the initial temperature? The initial temperature is 44. So I again go very close to 28 when times goes by. This is the graph for T equals to 28 plus 16e power negative 3 over 4t. Okay, and these are most of the things that you need to know, okay, for this chapter. The next video I'll go through and question that is inserting a suitable straight line.